Greetings of the day. I'm Manas Saloi of BTech ITDS SEM5, and I'll be presenting my project for machine learning algorithms, which is BMI prediction for health status using linear regression. So BMI is an abbreviation for body mass index. It is a person's weight in kilograms divided by the square of height in centimeters. A high BMI can indicate high body fatness. BMI screens for weight categories that may lead to health problems. We classify adults who are underweight, normal, overweight, or obese. Also, linear regression analysis is used to predict the value of a variable based on the value of another variable. So the variable we want to predict is called a dependent variable. The variable we are using to predict the other variable's value is called an independent variable. So linear regression is generally used to indicate quantitative values. So the first step we do is to import the required packages. We are using pandas for handling data. Then we are using sklearn model selection to split our data for testing and training. Then we are using the linear model package to use linear regression, which is built into it. And finally, the metrics package from sklearn to perform evaluation on our model. I'll import them now. After that, we'll read our data and do variables. So looking at our data, we have gender, that is male and female. We have height in centimeters, weight in kilograms, and this index represents like 1 for normal, 2 for underweight, 3 for overweight, 4 for obese. Now we have used this dot get dummies function to manipulate our data. So it converts categorical data into dummy or indicator values. For example, we have converted this gender into two columns, that is female and male. So it is represented by an indicator variable that is 0 for false and 1 for true. So in this case, so if the person is male, it will have 1 in the male column and 0 in the female column. Now we'll use isna.sum function to check our data for NaN values, that is any missing values. As we can see, there are no missing values in our data, so we can go ahead. Now I'll be performing it I'll be taking our independent and dependent variables. So our independent variable that is represented by X are height, weight, female and male, and a dependent variable, which is Y, is the index. That is, we have to predict it with the help of our model. So I'll perform a trend test split on our data, where the testing size will be 30% and the random state being 0. Now I'll be creating a linear regression object with the help of the package I've imported, and then I'll fit our data into it. This is for fitting the data. So now I'll be performing evaluation metrics on the model, that is mean absolute error, mean squared error, and R-squared score. So mean absolute error represents the difference between the original and predicted values extracted by averaging the absolute difference over the data set. And mean squared error represents the difference between the original and predicted values extracted by squaring the average difference over the data set. And while the R square is a statistical measure that represents the proportion of the variance for a dependent variable that's explained by an independent variable or variables in a regression model. In other words, how close the data are to be fitted in the regression line. So we have mean absolute error 0.47, mean squared error 0.33, and R squared error, that is R squared score, that is 0.789, which gives us the accuracy of our model, that is 78%. Finally, we'll use these two commands, .coef and .intercept, which is coefficient and intercept of the line. So using intercept and coefficient, if we input any other data, we can obtain the equation of a line, which will give us the output of the desired dependent variable, that is Y. That's all. Thank you.